Hello, my name is Dick Hill. I'm a Vice President here at ARC Advisory Group. Today I'm speaking with Tom Fiske, Principal Solutions Architect for Yokogawa Corporation of America. Tom, first, thank you for taking the time with me today.
You're welcome.
I have a few questions about the subject of autonomous operations and how Yokogawa is approaching this topic. First, I realize that this is a very complicated subject, but can you provide me with a brief definition?
Yes, Yokogawa has developed a detailed definition of autonomous operations, but for our discussions today, let's just say that industrial autonomy enhances industrial automation. Industrial automation performs a sequence of highly structured, pre-programmed tasks which require human oversight and intervention. Industrial autonomy goes beyond industrial automation by adding layers of smart sensing and machine cognition that anticipates and adapts to unforeseen circumstances, removing the need for human intervention.
Well, thanks, Tom. I've seen a lot of press and heard a lot of things about autonomous automobiles. In fact, I read a few articles that show the level of autonomous cars ranging from zero, where there is no automation or autonomy, to a level 5, where the car is completely self-driving. Does Yokogawa use a similar definition of various levels of industrial operations with regard to autonomous operations?
Yes, we do. For the past several years, both industry and the consumer markets have been adopting autonomous systems. We have seen significant progress in robotics, discrete manufacturing, self-driving vehicles, autonomous mining equipment, subsea operations, personal assistance devices, and many other areas as well. Now, autonomous cars, like you said, are characterized by 5 levels of autonomy, not including level 0, which refers to conventional cars where the driver has complete responsibility of driving the vehicle at all times. And autonomy levels 1 and 2, the car assists the operator with some tasks like braking, lane assistance, parking, and cruise control. However, the driver is primary operator and is responsible for its safe operations. And level 3, the vehicle monitors and controls itself using advanced sensors to detect changes to its surrounding and uses predictive algorithms and adaptive control for safety purposes. But there is still a need for a driver to take control in case of an emergency. And level 4, the car is capable of completely driving itself under certain predefined conditions. When these conditions aren't met, the human driver takes over. Level 5 is completely autonomous and requires no human intervention during driving. So similar to the autonomous vehicles, it's possible to define levels of autonomy for an industrial plant. For instance, in level 0, humans control the facility at all times. In level 1, humans and automation systems share the workload, with humans responsible for safe operations. In level 2, humans are responsible for safe operations, assisted by traditional automation and limited autonomous functions. In level 3, there is a mixture of autonomous and automated assets with human orchestration of the functions. In level 4, the facility operates autonomously in most normal operating states, synchronized to optimize manufacturing and safety under most circumstances. And in level 5, the facility is completely autonomous, including process operations, supply chain operations, and so on.
Well, that sounds very interesting, Tom. Where do you see the greatest need today for the movement towards autonomous operations?
Well, there's a lot of interest in many different areas because any process or operation has the potential to be made autonomous. This includes manipulating and controlling the process to other activities like manufacturing operations management, planning and scheduling, and supply chain activities. There is also the potential to make devices, equipment, or even entire process units operate autonomously so that they are self-aware and understand and adapt to the context in which they operate. Safety systems do a great job in bringing the process back to a safe state, but it's best to avoid those situations altogether. Things like fired heaters are operated with a high level of automation but require humans to watch over them. They're typically operated very conservatively to avoid any safety incidences. So this means that they're not run as efficiently as possible. With better measurements of gas, air, and fuel concentration, control can be adjusted to improve safety, reduce fuel consumption, lower emissions, increase throughput, and extend the life of the fired heaters. There is also potential to have touchless supply chains. This involves monitoring and managing a customer's inventory and triggering an order when supply runs low. The order could be processed autonomously from purchasing raw materials to scheduling, dispatching, and processing the order. Companies also have a need to operate safely and reliably while increasing sustainability, flexibility, and profitability. So any process that is prone to human errors or failure and has a significant consequence on any of these factors is a good candidate to make autonomous. In addition, any area where the loss of experienced workers could adversely impact conditions will become a focus of autonomy. The same is true in areas where workers are exposed to harsh, remote, or hazardous environments, and it's desirable from a worker safety standpoint to remove them from these environments. So to answer your question, the reality of autonomy in the process industries, I believe, is inevitable, and it's going to be revolutionary. Not only can production processes be made autonomous, but also higher level functions. Autonomy could expand beyond traditional controls and efficiency to include safety, reliability, margin optimization, compliance, supply chain management, and other manufacturing operational functions as well.
Tom, I can appreciate from your definition how this initiative is important to not only Yokogawa, but its clients. Overall, where do you think the greater majority of owner-operators are today in their quest for autonomous operations?
Well, the most forward-looking companies are beginning to think about autonomous operations. Many operating companies are making an effort to optimize the use and placement of human resources and in some instances achieve unmanned remote operations. Now, this is particularly true for highly complex, remote, and hazardous facilities, and some of the drivers are to reduce costs, improve reliability, and increase safety by removing the people from these hazardous areas. And so many of the steps necessary to achieve remote operations are also needed to achieve autonomy. For instance, they're converting manually operated equipment to fully automated. They're implementing procedure automation for manual operations, including complex operations like startups and shutdowns. They're using resilient and redundant communications, controllers, and critical equipment. And they're adopting intelligent sensors, advanced analytics, and artificial intelligence to monitor both the equipment and the process. And they are conducting remote monitoring, surveillance, and inspection, and looking to do these tasks by robots as well.
So I can understand those are great objectives for a lot of companies. Does Yokogawa have any clients that are started their autonomous operations journey? And if so, what are they trying to do first?
Well, I've spoken with a lot of the major players in the chemical and the oil and gas industries on this topic, and the response has been pretty universal. We need industrial autonomy, and we need it sooner rather than later. The demands are driven by anticipated benefits. This journey towards autonomous operations, as we call it, begins with our co-innovation process and helping companies adopt the appropriate digital enabling technologies to solve some of the most pressing business issues. Part of that entails working with the customers to implement unmanned remote operations and includes the use of robotic solutions as well.
Well, Tom, I want to thank you for helping us understand the breadth of the subject of autonomous operations. Do you have any additional comments you'd like to share?
Sure. So there are many benefits in realizing some level of autonomy in the process industries. Industrial autonomy will provide higher levels of productivity, flexibility, reliability, and profitability. It'll also reduce human errors and remove people from these hazardous areas. And much of the technology and data today to enable autonomy already exists. Various technologies like artificial intelligence are available that process the data and add intelligence that's necessary to achieve autonomy. In the near future, completely autonomous plants will probably be highly unlikely, but it's reasonable to expect that certain functions within a plant will be autonomous based on the applications, the needs, and the cost and the benefits. So, just keep in mind that companies may achieve some level of autonomy, like level 2 or level 3, and be in this state for a very long time as the technology, trust, and workforce dynamics evolve. And in these situations, human intervention and decision-making will remain an important part of the process, and so people must learn to work alongside autonomous systems.
Again, Tom, thank you very much for sharing your thoughts with us today.
You're welcome. Pleasure being here.